Hi guys. Okay, so today we're going to look at the derivative of a to the x, which is a number with x in the exponent, and log base a of x. Now we know that the derivative with respect to x of our natural exponential function e to the x is e to the x. Well, what if we want to know the derivative with respect to x of 2 to the x? We change the base. Let's go to our calculator and see what we come up with. Okay, so we said in F1 we're going to graph 2 raised to the x. There it is. And then in F2, we're going to use our template key with our derivative, d box of box. So we want the derivative with respect to x, tab over. You can either write 2 to the x again, or you can type in F1 of x. Either way is fine. Now, if I look at these, they are not the same. So we're not as lucky as when we did the derivative of e to the x. So they are not the same, but they do have a similar shape. So with that in mind, I'm going to add a page. In F3 of x, I'm going to graph F2 of x minus F1 of x to see if their distance is constant. Their difference is not. It starts out very small, but then their difference gets much bigger in the negative direction, meaning F1 is bigger. So if we switch this around, then it would be an increasing graph. So their difference is not constant. So now I'm going to add a new page. And this time I'm going to look and see if their ratio is constant. So now I'm going to control division to get a fraction key. And I'm going to put F2 of x in the top. And then I'm going to put F1 of x in the bottom. And we'll graph that. Now that is a linear function. I can see it. It doesn't change values. If we go on here and we trace and we look, that y value is always 0.693. It is never, ever, ever, ever changing. Okay? But what is that value, 0.693? Are you ready? I'm going to blow your minds. Remember, this function that we started with was 2 to the x, right? If we look up, if we tab up, remember this function that we started with was 2 to the x. And we did the derivative of 2 to the x. I'm going to put into F5 the natural log of 2, because 2 is the base. Look at that. Our quotient of the two functions is the natural log of 2. Okay, so based on what we have here, if we look at this, what we had in the calculator was F3 of x equals F2 of x over F1 of x, which equals natural log of 2. So that would mean that F2 of x over F1 of x equals the natural log of 2, which means that F2 of x equals F1 of x times the natural log of 2. Now, F2 of x was the derivative with respect to x of 2 to the x. F1 of x was 2 to the x times the natural log of 2. So we have just found that the derivative with respect to x of 2 to the x is the same exponential 2 to the x times the natural log of the base 2. Let's see if we can generalize that for any base a. So a is some constant. So we have y equals a to the x. And we want to get the x out of the exponent, so I'm going to take the natural log of both sides. Okay, now I'm going to take the derivative, because I didn't know how to take the derivative when the x was in the exponent, so I needed to get it out, and the only way I know how to do that is to take the log of both sides. Okay, so the derivative of natural log of y is 1 over y times, don't forget the chain rule, dy dx equals, the derivative of x is 1, but it's times a constant, so it's just that constant. Remember, this is like having the derivative of 3x. It's a constant natural log of a. Remember, this is just a constant times x, so the derivative is just that constant, okay? And then if we solve for dy dx, that would be y times the natural log of a, but what was y? Y was a to the x, and now we have a rule. So the derivative with respect to x of a to the x is the same exponential function a to the x times the natural log of a, And remember, if we do this with the derivative with respect to x of a to the u, it's a to the u times the natural log of a times the derivative of u with respect to x. That's just the reminder to use the chain rule. Now there is one little note here. If you think about our function y equals e to the x, we said that derivative is just e to the x, but it's an exponential function. It should follow this rule. That means dy dx should be e to the x times the natural log of the base e. But what is the natural log of e? It's 1. So dy dx is e to the x does follow that same rule. Okay, so it's not that there's a new rule, it is the same rule. Next up is the change of base formula from Algebra 2 and Pre-Calc. If you don't know this rule, I want you to know this, because I'll be honest, most of my kids don't memorize this rule. We don't like to memorize things we don't need to know. And you already know how to take the derivative of a natural log. So if you can do that, you can take the derivative of the log of any base, okay? Because the change of base formula, if you have the log base b of x, you can rewrite that as natural log of x over the natural log of b. And it could be any base, but we're going to use the natural log because we know the derivative of the natural log. So for instance, if we're going to use the change of base rule to do this. And we're going to use base e. So if we have log base a of x, that's going to become the natural log of x over the natural log of a. Now we're going to take the derivative with respect to x of both sides. And keep in mind that natural log of a is a constant. So when we take the derivative over here, we're going to keep the constant 1 over the natural log of a. Then the derivative of the natural log of x is 1 over x. That means that this derivative is 1 over x times the natural log of a. We just proved it. Now, you can choose to memorize this rule, or you could use the change of base rule and just use the derivatives you already know. That is totally up to you. Don't forget, this is use the chain rule. Okay, let's try an example. So if we have something like this, if we follow the rule that's here, okay, if we follow this rule, then the derivative with respect to x of the log of 3x plus 1 is going to be 1 over 3x plus 1 times the natural log of 10, because the base on a log with no base written is 10, times the derivative of the inside, the derivative of 3x plus 1 is 3. Just neaten it up a little bit. And now we have our answer. Okay. Now the other thing you could have done, if you don't want to memorize that rule, you would say, okay, the derivative with respect to x of the log base 10 of 3x plus 1 is the natural log of 3x plus 1 over the natural log of 10. The natural log of 10 is a constant, so it stays, times the derivative of a natural log of something is 1 over the something, times the derivative of the 3x plus 1 is 3. And notice you get the exact same answer. So the question is, do you want to memorize the new rule, or do you want to use the process using the change of base formula? That's up to you. Okay, let's try some derivatives here. Now remember, I'm going to put up here, this is not one of those log rules, so I'm going to remind us here, the derivative with respect to x of a to the u is a to the u times the natural log of a times du dx. So if we look at this, the derivative of y is dy dx. The derivative of 2 to the x is going to be 2 to the x times the natural log of the base is 2 times the derivative of the exponent is 1, so we're done. Over here, the derivative of y is dy dx equals, and we have 3 raised to the x squared plus 2x. So we keep the exponential function times the natural log of the base 3 times the derivative of the top, which would be 2x plus 2. And there we go. We've got our derivatives. Okay, one more example. This looks familiar to me. The limit is x heads to 0 of 5 to the x minus 1. Now notice it's head to 0, so this would be x minus 0 in the bottom. But does this minus 1 fit? 5 to the 0, remember, is 1. So yes, this is the limit as x heads to 0 of f of x minus f of 0 over x minus 0 when f of x is 5 to the x. And they want us to find the derivative at 0. So the first thing we need to do is find the derivative of 5 to the x, which is the exponential 5 to the x times the natural log of the base 5. So if we want the derivative at 0, that's 5 to the 0 times the natural log of 5, which is just the natural log of 5, which is choice B. All right, guys, there we go. So you do have to know the rule for the derivative of a number raised to the x, and then you have your choice on whether or not you want to memorize the rule for the log of a base other than e, or if you want to use your change of base rules. All right, guys, have a wonderful day. See you soon.